Welcome to the IUPI Well Construction Process module in the reservoir development phase of the E&P life cycle. Before beginning this module, you should have an understanding of the well design process. This module covers the processes involved in constructing a well. At the end of this module, you should be able to describe the drilling, casing, cementing, and completion processes. Describe the tools and techniques used to drill deviated wells. After the well has been designed and the well plan written, it is time to begin the actual construction of the well. In this module, we will trace the sequence of operations that are undertaken in order to construct a well. Well construction begins with the processes of drilling, then casing. The hole is drilled in stages, and at the end of every stage, casing is put into the hole and cemented into place. After the well has been drilled to final depth, and all of the casing has been cemented into place, the well is completed. Completion refers to the operations that must be performed in order to prepare the drilled hole for the production of oil and gas. Before covering the drilling and casing process, it will be helpful to identify the basic components of a drill string. The drill string consists of the pipe and other equipment that are used to actually drill the well. We will discuss the drill bit, which is the rock cutting tool, and is connected to the bottom of the drill string. The portion of the drill string above the drill bit is known as the bottom hole assembly, or BHA. The BHA is made up of drill collars, which make up the major part of the BHA, stabilizers, which are placed strategically in the bottom hole assembly, drill pipe, which makes up about 95% of the length of the drill string. For directional drilling, additional tools are installed in the bottom hole assembly. These tools include the navigation sub, the mud motor, and measurement while drilling tools. In slim hole drilling operations, coiled tubing can be used instead of drill pipe. There are two main types of drill bits used today: roller cone bits and polycrystalline diamond compact, or PDC bits. Roller cone bits are also called rock bits or tricone bits, and they are the most common type of bit used worldwide. Two basic kinds of roller cone bits are available. One, called a mill tooth bit, has steel teeth which are cut from the cone, and the other, called an insert bit, has tungsten carbide inserts which are set into the cone. Roller cone bits have three cone-shaped devices with teeth or cutters. As the bit rotates, the cones and cutters rotate to drill the rock, using a chipping and grinding action. The polycrystalline diamond compact, or PDC bit, was introduced in the 1980s. These bits use small discs of synthetic diamond to provide the cutting surface. The hardness and wear resistance of diamond make it an obvious material to be used for drilling. The cutting action of a PDC bit is achieved by scraping away the rock using high RPM. PDC bits are expensive, but they last much longer than roller cone bits and can be used for long bit runs. This results in smaller numbers of round trips, and so the high cost of the bit is more than offset against the rig cost for tripping. Drill collars are very heavy, thick-walled pipes. A typical diameter for a drill collar is 9.5 inches, or 240 millimeters. The drill collars are used to provide the weight on the bit required to achieve the rock-cutting action. Stabilizers are positioned above the bit in the BHA to help guide the bit in the direction it should drill. Stabilizers have blades that centralize the bottom hole assembly in the hole. Drill pipe is thin-walled, lightweight pipe. It is very strong, however. Drill pipe forms the major part of the drill string. A typical diameter for drill pipe is 5 inches, or 125 millimeters. In directional drilling, special tools are needed to enable the well to be drilled at an angle to the vertical. Usually a PDC bit is used, since this eliminates frequent trips to change the bit when it gets dull. Attached to the bit is a navigation sub. The navigation sub tilts the bit at a predetermined angle. Another tool used in directional drilling is the mud motor. The mud motor is used to rotate the bit. In conventional drilling, the top drive, as shown in this video, or rotary table, transmits rotary motion to the bit by rotating the entire drill string. In directional drilling, the straight hole portion of the deviated well is drilled just as in conventional drilling. The entire drill string is rotated. The tilt angle of the navigation sub is very small, and therefore the eccentricity of the center of the bit is small. Thus, this assembly can be used for straight hole drilling. When the build section of the well is reached, the rotation of the drill string is stopped. The circulation of mud drives the mud motor, and the drill bit still rotates. The rest of the drill string, however, does not rotate. This allows the build section of the hole to be drilled. Measurement while drilling tools are placed in the bottom hole assembly to assist the directional drilling procedure. MWD tools contain sensors which can measure the inclination and direction in which the well is being drilled. This data is transmitted to the surface. There, the driller monitors the conditions in real time. Most MWD tools transmit information in the form of pulses in the drilling mud. These pulses carry the downhole information up the drill string to the surface. An MWD tool will produce fast, accurate data on the hole inclination, azimuth, and the bit, or tool face orientation. MWD tools can also measure rock properties, torque, and weight on bit. To steer the hole during kickoffs or course corrections, the system is oriented using MWD readings, so the bit will drill in the direction of the navigation sub's offset angle. Slight deviations from the desired angle can be detected and corrected with minor-oriented drilling intervals before they become major problems. When drilling slim hole wells, coiled tubing, or CT, can be used in place of the drill pipe in conventional wells. Coiled tubing is small-diameter seamless pipe that is manufactured in lengths of thousands of feet or meters. The diameter of the pipe ranges from 1.5 inches to 2 7/8 inches, that is 40 to 70 millimeters. The tubing is wound onto a large drum for transportation and deployment. Coiled tubing drilling, or CTD techniques, have many advantages over conventional drilling operations. First, coiled tubing drilling requires less personnel on board the rig. The decrease in pipe size and weight reduces the risk of personnel injury. Drilling underbalanced is generally considered safer using CT than drilling underbalanced with a conventional rig. Coiled tubing is much easier and quicker to run in and pull out of the hole, since there are no connections to be made up or broken out. With CT, the mud circulation does not cease during the drilling operation, so drill cutting settlement and drill pipe sticking is reduced. Some disadvantages of using CT as the drill string include: it is limited to smaller hole sizes, and it is not possible to rotate the string for orientation of downhole devices or to help prevent pipe sticking. Therefore, special hydraulically operated devices are required in directional drilling. Now we are ready to go step by step through the well construction process. We will examine the following procedures: installing the conductor casing, drilling and casing the surface hole, drilling and casing the intermediate hole, drilling and casing the production zone, and evaluating the well. The hole sizes, casing sizes, and depths are different for every well, but for this course, one particular standard configuration has been used. The first stage in the well construction process is to drive the conductor casing, a large diameter pipe,